really an Algebra 2 topic, okay? So we've had lines, Cole, and lines look like y equals mx plus b. So the exponent on x, because you see 1, is just 1. The exponents on these things called parabolas are quadratics. These are quadratic equations. That's why this is called quadratic algebra, is we're going to look at the mathematics when the exponent on x becomes 2. If you let the exponent become 3, they're called cubics. And we could take our graphing calculators and play with some of these other functions to see what they look like. Okay? So this is just the regular general form. A and B and C, I'm going to give you the real word for them. They're called constants. They are just plain old numbers, like 1, 2, 3. They could be negative too, by the way. And we had a little practice graphing some of these yesterday. So that's just general form. Generally speaking, that's what I look at when I look at quadratics. Okay? Then we have a factored form. Sometimes you can factor this quadratic. Not always. Remember how we factored like x squared plus 5x plus 6? Well, we could graph that, and we could actually make a table of values and see what the shape looks like. I know it looks like this. So I'd like to come back and look at that worksheet when everybody's done with it. Because you know how we had some quick graphing for lines? We used the y-intercept and the slope, and we could graph it really quickly. You did not like doing tables because you knew how to graph it quickly. Well, I can do the same thing with parabolas once I find where this crosses the x-axis. Okay, so if I could factor this, do you guys know how to remember how to factor that? Remember you have x and x, right? What are the signs going to be? Plus and plus. 5, 6, it's either 6 and 1, but that adds up to 7, or it's going to be 2 and 3. So it's 2 and 3. Okay, that's factored form. This is going to give us some information about where our parabola is graphed in the plane. So you're actually going to learn some real mathematics. Before we learn skills, how do you factor? Okay, Ray, so that's all we've done. There's another form. Do you remember that when we graphed our parabola, we had a lowest point here? That was called the vertex. Well, I can give you a parabola in vertex form. There could be an A in front of that. And I'm going to put an A there because it doesn't have to be 1. There could be a number there. So I'm finding fault a little bit with this, but that's okay. An A, well, that tells you a lot of stuff. It tells you if the parabola is skinny or if it's wide. We don't have to worry about it in this class. But we are going to worry about the vertex. But we'll get there. So those are the 3 forms that we're going to look at with parabolas. And there's another form of vertex, but we'll leave it just the way it is right now. Is that okay? I just don't want to lose you. Remember what this all stems from. It stems from these pictures. So when they design a roller coaster, it's all physics and it's all math. Because if they don't design it right, when you're in the roller coaster and you're going upside down, if they don't figure out all the forces correctly, you will fall out of the seat. No, but they have engineers that do that. That's what they do for a living. They design these things. But unfortunately, there's no right answers because there's no answer key. So then you have teams of engineers. They work at it. They test it. They build models. They test it. Does it work? You don't just go into a building without models. Luckily. Although sometimes it happens and then we have some problems. Do you remember domain and range?
Yes.
What's domain? Generally speaking, they're going to be our x values. They could be our t values if you're talking about time.
And range is y in that.
Okay, but what's a more general word? When you have, I can't do that, y equals x squared, the x's are the numbers that you put into the equation. They're the inputs. Let's keep it simple, inputs. How about that? And then I will also put this up on the website. And so if you want a colored copy, of course you have to print it out in color. But if you want your own hard copy, you can print it out. And what did you say the range was, Henry? Outputs. Outputs. Generally speaking, we call it the y. But if you're talking about velocity, it might be your velocity. It might be your position. These should sound familiar from science class. What are you studying in science right now?
Physics.
Yeah, but what are you studying?
Physics.
What part of physics?
Oh, the momentum and the watts and
The momentum. Well,
Well,
that's what they're studying in science. Okay, those acceleration and the momentum, those are all your outputs. Well, what do you do? How do you find momentum?
P times.
What's
no,
P?
P's momentum is M equals mass and
Times.
acceleration.
No, velocity.
P equals M.
mv.
V, yep.
What's force equal to?
M times A.
Yep, and your mass is constant, so your acceleration is what changes. So those are your inputs. Okay, I just want you to get the idea it's not always x and y. Okay, ready? Okay, so we are going to graph, and I think there's something more there, but let's, what happened? Well, that's not good. Let's look at y equals x squared.
iPad's still not working.
Well, you can take notes. I don't know why it's not working. Okay, what's the easiest value we can put into this? What's the easiest input? 1. Mariah doesn't like 0, right? What's 1 squared?
2.
No, 1 squared. 1 times 1. Sorry, I was rippling my board.
How am I supposed to do these?
You can just draw a little sketch. It's not fancy. I can give you graph paper too if you're really fussy. Okay.
Can I have that?
You have to ask me that. Well, what's another nice x value? What's the easiest x value in the world? 0. Put in 0. Well, I said I had graph paper. I'm not going to swear to it. There she is. Anybody else wants graph paper? We're going to graph on our iPads or a graphing calculator. Oh, you want a better one than that? That one's kind of crunkled. There you go. Good. So put in 0. That's another nice one. What's 0 squared? Oh, Mariah's favorite number. What's 0 squared? 0 times 0 is?
0.
0. Doesn't exist, right? Okay. What's another good number to put in?
2.
2. And when you square 2, you get
4.
4. How about another one?
3.
3. And you get?
9.
Now, you know why they're called perfect squares? No. Because if you take a square with side 1 and side 1, what's the area?
4.
What's 1 times 1?
1. 2.
What if you take a square that has sides 2 and 2? It's a square.
2.
What's the area?
4.
4. What if you do 3 by 3? What's the area? How many squares fit in it?
9.
That's why they call them perfect squares. The sides are nice numbers. Okay? Because they form squares. Well, you know what, you guys? Cole, how about if I do it some negative numbers? What's a negative 1?
0. 1.
It's 1.
Bam.
Now, they didn't give me enough space here. What's another one to try?
Negative 2.
What's a negative 2 squared?
4.
Positive 4. What's a negative 3 squared?
9.
9. Okay, let's graph these. I have some dots here, but anyway. Okay, 1, 1. Then I have 0, 0. Can you guys put dots on there?
Yeah.
2 is 4.
Yeah.
3 is 9. Whoops, a little bit off. Now, there's some symmetry here. Is the left side going to look the same as the right side? Symmetry. Your face is symmetric. Actually, it's not. It's pretty close. If you ever taken a picture of your face and taken one half and then reflected it over, you look totally different. Your face is not as symmetric as you think. That's what you mean by symmetry. If I cut a line here, these two sides should look the same. So if I do this over here, if I try negative 1, I get 1. I'm going to show you the quick graphing because we're here. Negative 2 and 4. and negative 3 and 9. Notice I'm not working real hard to get this point because I know where it is on the other side. If I put a mirror here, okay, Henry, these sides are the same. And you can connect these little dots. And they're smooth, by the way. So if you didn't do the y equals x squared, there it is. I want you to notice there's some nice, neat ways to do quick graphing with these, provided that the number in front of x is 1. If I go over 1 and up 1, like slope, right?
And then 1 over 3.
If I go over 1, I go up 3.
And then 1 and 5.
Then this is 1 and then 5. So if I went over 1 more, how many would I go up?
8.
1, 3, 5.
8.
How are these different?
They go up by 3.
These go up by 2, so this will be 7. So there's lots of quick graphing for different kinds of functions. Parabolas are useful. So that's kind of cool. I'll let you think about what happens with the 2. Okay, so let's look at our domain and range because we had a little problem with this yesterday. What's the domain? What can we put in here? Was there any, could I put in negative 100 if I wanted to?
Yeah.
Henry?
Don't take too much.
I could put anything in.
Yeah.
Some of you have learned some calculus notation and you found it was easy. We're going to go from negative infinity to positive infinity. For those of you who don't like that notation, you can say any number. Any number. We only have real numbers. There are such things as imaginary numbers. They're not imaginary. Yeah. What's the range?
1 and infinity.
Not 1. It goes all the way down to what?
0.
0. How do I write that so I can include 0? I can do it this way. It's a bracket, 0 to infinity. And that's what we do. We don't usually introduce that notation until pre-calculus. I don't think it's that hard. Or you could say y is greater than or equal to 0.
For a bracket, does it matter if it's bracket?
Yeah.
Yes. If you do this, if 0 to infinity, I probably won't be that picky because we're just learning it. But this would be y is greater than 0. Are they the same things? No. This is the one I want. So I close the bracket if I want to include it. Okay. Is that okay? That's not that hard. This is not that hard. That's part of it. Okay, what's the next page? So we're going to do some stuff. Find the domain. Okay, this is now going to be trickier. Find the domain and range for this function.
The domain is 5, -5.
Domain is what can you put in? It's a parabola. I don't know what the name of the function is. I do, but you guys don't. Yeah.
If we don't have it, add that to your range down.
Yeah, you can just draw a quick sketch. Notice, before we do this, where's the vertex? Where is this point right there? -2, comma. Oh, I can't get this wrong. -2, right? Kind of like those that I can't get wrong. -2, -2.
Just write that down.
Does my little pattern work? I go over 1, up 1. I'm going to go over 1, up how many? 3. I'm going to go over up 1, and I should go up 5. Yeah. So it tells me a lot, actually.
No, it's not.
Okay. What can you put into this? Can you put in a negative number?
Yes.
A positive number?
Yes.
You can put in any number. That's your domain. So everything, if you could draw this forever, this would go off like this. It would pick up all the x values. The range is a little trickier. Just think of, let me try doing it this way. Let me try it with my shade. Okay, you can't get -4. You're not going to get -3 on your y's. What's the smallest y value you can get?
0.
Y's, just the y's. There it is.
-2.
-2, and it goes all the way up. Does this help visualize that? No? Because you're looking right here. You aren't going to get -4. The graph didn't come down here. Just think of this horizontal line. Horizontal line starts at -2 and goes all the way up. Let me get rid of that. So, what's the range? We will have a worksheet for this, yes. What's the range? -2 to where? Infinity. When you do the range, you're looking at these horizontal lines and where they hit like that. The domain is a vertical line like this, and where will that hit? That will hit every single x value. As that gets bigger and bigger, it just comes across like that. Now I just got you to a vertical line test, but that's okay. Okay, what's the next one? Let's try that one. And I get, what? You want this one back? Whoa. That one back again? Yeah, you can put graphs on. First, find the vertex, because that's going to be important.
I got it now.
Okay, where's the vertex on this one? Suzanne, where's this one? What's the x value? What's the x? I do my things alphabetical. What's x here? No, that's y. 2. And the y value is -5. Is this the standard parabola? Over 1 up 1, over 1 up 3, over 1 up 5. Yep. Okay, what's the domain?
Infinity.
Everything. Even if you say infinity, I'll take it. We never close infinity because you know what? We never get there.
Yeah, I'll take like.
We never get there.
So someone said like 1, would you take it?
No, I want all values. If you say infinity, that tells me everything.
It's anything, so.
No. Infinity tells me everything. 1 tells me just 1. Now, where are these y values going to be? Whoops, grabbed the wrong thing. Sorry.
Yeah.
Are they going to be down? Come on. Are they going to be down here? Where do they start?
2.
The y's.
Oh, 5.
-5, and they go up forever. So what's the range?
Range is 2.
What's it start at?
Wait,
-5, and they go to infinity. You could say y is greater than or equal to -5. Which way do you like better?
-5.
Do you like this one or this one?
Bottom.
I like the bottom one too. It's faster. To me, it's faster. Okay? Any questions on that? Is that okay? I don't think there are a whole lot. Oh, and then we're going to go to Quick Graph. Now, this is Mr. Johnson, so that's his wife and his baby. You have Quick Graph on your iPads, I think. Or you have a... Yeah. There. Happy. What's pi? Oh, math formulas. Do you have Quick Graph on your iPads?
Yeah.
Do I have Quick Graph? I have a... Oh, now, if somebody wants to borrow my Inspire... Who doesn't? Do you want to try the Inspire? You want to try it?
I want to try it.
Inspire calculator is the latest and greatest, but it's finally on the iPad now. Okay, so we are going to go to... Oh, keep my changes. Okay, we are going to go to... I got to figure out how to do this. Huh. Add, and we're going to add a graph. There you go. And I'm sorry, I can't put it on yours. Okay. Okay, you guys, in your Quick Graph, you're going to try to type this one in. You'll need a calculator. Anybody who doesn't want to use their iPad calculator may use one of my calculators. I have other Inspires, not as nice as what's on my iPad. So either use your iPad calculator or use one of mine. If you don't have your iPad here, you'll need one. Let me give you a worksheet. Okay, or you can do graphing calculators on your phones, but they're not as very good. If you have your own graphing calculator, do you need one?
Yes.
Take the blue, it's easier. Well, we're doing this problem right now. So type in y equals. Now, I'm not sure how to do this on there. Here, you want a calculator? So you want to type in this one. Y, okay, it says add. Okay, you guys, if you're doing Quick Graph, add. Did you find Quick Graph?
Yeah.
I've never done it, so I don't know. Okay, so you go add, and I could put my iPad. So you're just going to add, you're going to type in parentheses x plus 2 squared.
No, but what's with the F1?
That's where you're going to put it. It's y. F of x is y. Yeah, so just type that in. So this is what you're going to type in. And you should see this picture. Okay, that's what you should see when you do add. Y equals. Did you type it in?
Oh no, you want to do it for me?
No, I know how to do it.
Can you show me?
Turn it on. Oh, we got to clear all these things out. Yeah, somebody thought they were funny.
Where's that at?
This is, you can use one of my calculators, or you can.
Wouldn't that be cool if the calculator was touchscreen?
It is. If you tried the iPad,
Well, no, I don't want to do that.
I mean, my iPad, yeah, it's touchscreen.
No, I mean if that was touchscreen.
Same difference. Now, parentheses.
Those are cool.
Oops, wrong parentheses. Where's my clear? You do it. Okay, you guys, you're going to type in x plus 2. So you're going to do x, parentheses, x plus 2 squared plus 1. So we're going to do more stuff with calculators this semester, and you may be choosing to buy one. So in a quick graph, you have to go to quick graph. So you have to close that off and type in QU. You should have it. Quick graph. Go down. There you go. And then you go up to the plus. See the plus? That's how you add. Type it in.
How do you do plus? Like the or
Right here.
two?
Oh, squared? It's x squared right here. Yeah, I could do 3 different calculators at once because I have the Inspire.
Okay.
How about you? Did you get it in?
How do you get it? Oh, never mind. One.
No, you're up in the exponent. Oh, there you go. Perfect. And you know what? If you don't like the color, let's cancel. Color is here, maybe? No. Tools. Maybe the color's in here. There's a way to, maybe if I,
Right here.
there is a color in it. Yeah, you'll play with it. Okay. Now,
How do you get the squared?
oh. Yes. That's how you get the squared. You put a 2.
Like that?
Mm-hmm. Plus. Okay? So you have, she's right. I didn't think about it. Oh, look at this. Did they give you that
Yeah.
on your quick graph? They won't on the Inspire.
Oh, no, they didn't.
By the way, you want it x plus 2, and then you have to do the caret squared. So Suzanne, yours is different. Did you try it? Are you stuck? Okay. Nice. That is really nice. I'm pleased. But you can't touch it and drag it. That's all you can do. Can you do anything with, oh, you can do that with your axes.
Yeah.
Hey, you guys, you can pinch your axes on this quick graph. We're just graphing these. So you can't do it on a graphing calculator. What I could just do it on the iPad. So you're going to graph it. What do you mean you don't have one?
We've already gone through this. I left it at home.
Today you don't have one.
Yeah.
Oh, I thought you meant you didn't have one. No, yes you do. So first you have to turn the calculator on.
Are we gonna turn in this?
Sure.
The points?
Sure. That's what gets you to do it.
Caitlin drew all of mine, so
Okay. Where's your iPad?
right there.
Why don't you use it?
Because it never loaded, remember?
Oh, well you could do the quick graph. So you go y equals, there's nothing in there, and now you type in parentheses, x plus 2. There's no squared button on our quick graph. No, you have to use the caret. Cole, do you have it? Let me see your graph, Cole. What you're supposed to be doing on quick graph.
Whoa.
Good, you don't have anything in there, so press plus.
Graph. I thought it doesn't do anything.
What is all that noise over there?
I just guessed. Okay, shh, put it in. Okay, you guys? You type it in, and you won't get, until you press this button right there, you won't get the graph. Yeah.
Where's the carrot at?
The caret is down here someplace. Let me see. It is right there. Yes, you have to do the caret. I don't see a squared button here.
Do after this, like it's been on my screen for like 5 minutes. I don't know if it's
Oh, and then you are going to do something different. We're going to zoom it for it.
okay.
And there it is.
So that's all we're doing?
Yeah, we're graphing it. Now you got to read this point. So if you trace, you can find that point.
So what?
Trace, 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 trace.
Do I write it down somewhere?
Yeah, you could graph it because you can find where this point is
But
at the
it's
bottom.
right there. I can't just take a picture of it or something.
Yes, you could do that. I want to find the bottom point. And there it is.
-2.
-2, 1. Look at, I mean, and the quick graph actually is a little nicer than the graphing calculator, surprisingly enough. You guys, can you read that point off?
Yeah.
But now it's up here. I'm not sure why it's written on this. So QuickGraph must be able to do that. So I'm going to have to look over somebody's shoulder. You can find it on yours. You're going to press second and then calculate. Second. Calculate. And this is the lowest point on my graph, isn't it? So go to minimum. Yeah, keep going down. That's right. Press enter now. And then it says, I want to look for this minimum. So I want to be to the left of that minimum. Press enter. Then go to the right. Keep going until you get past the minimum. So it's going to look only in that range. Okay, cool. Press enter. Can't hurt it.
Cool.
And then they say maybe there's more than one. So we're going to ignore it. We know there's only one there. So press enter. And there it is, negative 2, 1. That's your vertex. Your vertex is your lowest point. Okay, so there must be something here that we can do. Whoa.
Let's go investigate. That's what we got before.
Well, that's what we found, yeah. Yeah, well, there's a relationship between this vertex and that equation. You guys, the vertex is at negative 2, 1. Here I have y equals x plus 2 squared. Okay, you guys? You guys, the vertex is at negative 2, 1. There's a relationship there. Okay, well, pay attention to this. How is this negative 2 related to that positive 2? What's true about these two numbers? They're opposite. What's true about these two numbers? Whoops. They're the same. These are the same but opposites. I don't know what the next one is. Okay, so we want to graph that. Do you want to try your quick graph first?
Can I grab it?
I don't have quick graph, but I have a TI. So I'm going to go ahead and bring my calculator, maybe. Where is my guy? TI tools. There it is. Now, it'll be the same as Ray's. Who wants to come up and operate the calculator? Lala was first. I don't like key press history. So press Y equals, let me move this. Yeah. I'm sorry, is X the same as what? X is X. I don't understand the question. X is X. I do, but I'm not prepared for it. But you could study. Did you get your stuff done? Suzanne has gotten into 3D graphing. Quick graph is pretty good, actually. Okay, X is right there. Yeah, X minus 7. Does anybody have a prediction where the vertex might be? 7 and what? What's the other number there? Okay. And press zoom 6. Zoom is up here. Then we don't have to set the window. And then go to 6.
So much fun.
Woo! There's the vertex. Okay, guys? Oh, well, why don't you wait? Henry, come here. Okay? Henry wants to find that lowest point. Well, we're going to learn. This is a minimum, isn't it?
Yeah.
So now you guys are going to be able to find the vertex. I don't know how. Oh, because you have a good graph. You could read it right off there. My graph isn't good enough, is it? Okay, so Henry, come here. Second, and then calculate.
Which one's calculate?
Come here, second. You have to do second. And then calculate. See the calc? And you want a minimum. So, whoops. My mistake. I hit my elbow. Okay. Okay, got to do again. 3.
3?
Yeah. Oh, you could arrow down. Now, you want to find the minimum. So you just have to move your cursor.
All the way down.
Oh, I'm wrong side. I had to look at the values. Henry, wait, tell me when you see the cursor coming. Oh, there it is. Okay. So you want to pick a point to the left, press enter. And now use the arrow key. Yeah, don't be quite so hard. Go to the right until you've gone past the minimum. There you go. Now you can press enter. And then it thinks there might be more than one answer. Just press enter again. And there it is. 7. Okay, guys. We're almost done here. No. Okay, you guys. The minimum is at 7, -2. Okay, you guys. Shh. Henry, have a seat, please. Ray, have a seat. Is that mine? Okay, guys, you've been really good. Let's get this done. How do you think these relate? The vertex. If this is -7, what's this? +7. This is -2. That is, sorry, this -2, that's -2. So the vertex is the opposite of this one and the same as that one. So let's graph it. Now, you guys, I found the bottom point. Remember the rule? We go over 1, up 1. We go over 1, up how many? 3. 1, 2, 3. I don't expect you to get it all the first time, okay? Over 1, 1, 2, 3, 4, 5. Let's do the same over here. It is fun. And there it is. Not the greatest parabola in the world, but it's, you got the idea. Don't you like the patterns? I love the patterns. Yeah, let's type it in on that little one. And then, let me see what the next thing is. Uh-oh. Oh, wait, we didn't answer this. Oh, what's the domain and range? I'm going to help. Oh, where'd my iPad go? Oh. Well, this is like a worksheet. Okay? Shh. Yeah, we probably won't get to the worksheet. Okay, guys. What's the domain?
Domain is -2.
No. By the way, I'm lazy. The domain, what x values can you put in there? Anything you want. What's the range? -2 to infinity. Okay. Using your quick graph, okay, Henry, we're going to do the next problem because we probably won't get to the worksheet today. It's okay. Let's graph that.
Can I graph it?
Yeah. Do you want to use on my graphing calculator? I don't have a nice little quick graph here. And then again, it says, I have to slide it down, sketch and find the domain and range.
Wait, I don't want to graph. Can I go just get a drink?
A very quick drink.
Thank you.
But I want you to come back and graph this. And now your buddies are out there.
Who?
I don't know, but I'm going to kick them out.
I don't know these guys. You're going to pick them off? You're going to kill them?
No, I'm going to kick them. Graph that one. Try x minus 2, x minus 4. Just have to graph it, that's all. Okay, Cole?
Yeah.
Yeah.
I can't see the sign. Don't try to read.
It is. It is.
I hate the phone.
Oh, where did my graph go? I moved things and there it was. Okay. There you go. Y equals. You just have to type that in. Clear that out. X minus 2, x minus 4. Those x minus 2s, x minus 4s have a meaning. What? No, the bell's going to ring in like 3 minutes. Now, you guys, with the quick graph, you're going to have to tell me where the vertex is because I do know where it is. No, you're okay. Just press graph. Just press graph. There it is. If you want to grab it and drag it down. That's cool. Yeah, you could center it there. Hey, Lalo, I know it was a hard day.
Yeah, it was a hard day. Okay, so
There it is. Where's the vertex?
2.
Where's the x coordinate? Is that 2? No. Where's the x coordinate? Okay. Taylor, go sit down, please.
Yeah, Taylor, go sit down.
No,
On a desk, ma'am.
It is on a desk.
no, in the desk. Okay, guys, we're not leaving till you sit down because I'm not done. Have a seat. Jake? No, that's not your desk. Okay, you guys, these are called intercepts. When you get it in this form, the vertex is halfway between 2 and 4. What number is halfway? That's right. My guess is it's at the y value is -1, but you guys will have to tell me, is it? I don't know. You guys,
Somebody just farted.
what is that? Looks like -1 to me. See if I can get that better. Still not right. Hey, you guys. Shh. What's the?
Oh my God! He just farted, Miss Lombeski.
That's forever on the video.